Welcome to Basic Concepts of Surveying.
Introduction and Objectives of Surveying. Basically, surveying is the science and art of measuring distances, angles, elevations, and positions on or near the Earth's surface. Now we discuss the purpose of surveying. Why do we survey? The main purpose of surveying is to provide accurate data. This data is the foundation of all civil engineering and land management projects. For planning, it helps design infrastructure such as roads, railways, and city layouts. For design, it supports the construction of structures like dams, canals, and bridges. For execution, it ensures that works are carried out at the correct location and with proper dimensions. So we survey because it is impossible to plan, design, or execute development projects without accurate ground information.
Surveying has wide applications across various domains that are mainly land boundary determination, cadastral surveying, topographic mapping for environmental studies and resource planning, disaster management, flood mapping, and urban expansion studies, land governance, title registration, land acquisition and valuation.
History of surveying in India. Surveying has a deep-rooted history in India. Evidence of land measurement dates back to the Indus Valley civilization around 2500 BCE. Use of standardized weights and geometric tools. Arthashastra by Kautilya, 4th century BCE, mentions land classification and revenue assessment systems. Early forms of cadastral surveys were used to determine land ownership and tax. Next, the medieval period. Mughal Empire introduced more organized land revenue systems. Todermal's land revenue e-forms under Emperor Akbar, 16th century, included detailed land measurement and classification, Zabit system. Use of chain and staff surveys, rudimentary but systematic. Colonial period, 1600 to 1947. British introduced conventional surveying techniques in India. Establishment of the Survey of India, 1767, one of the oldest surveying institutions in the world. Initiation of the Great Trigonometrical Survey, 1802 to 1871, for precise mapping. Development of revenue surveys, topographical surveys, and cadastral mapping for administrative control and taxation. Post-independence, 1947 to present. Focus shifted to nation building, infrastructure planning, and scientific land administration. Adoption of modern instruments like theodolites, total stations, and GPS. Establishment of survey training institutes and introduction of degree diploma programs in surveying and geomatics. Integration of geospatial technologies like GIS, remote sensing, and UAVs in land surveys. Implementation of Digital India Land Records Modernization Program, DILRMP, to digitize land records and improve transparency.
Survey of India. Set up in 1767 to help consolidate the territories of British East India Company, it is one of the oldest engineering departments of Government of India. This slide highlights one of the most remarkable milestones in the history of surveying, the Great Trigonometric Survey of India. It was a landmark scientific project conducted by the British from 1802 to 1871, covering almost 7 decades. The main aim was to map the entire Indian subcontinent with very high precision, using the method of triangulation, which meant measuring large distances and positions by forming long chains of connected triangles. This massive project was led by notable surveyors such as Colin Mackenzie, George Everest, and Andrew Wow. It established a vast network of survey stations across India and created the scientific base for modern mapping. One of its most significant achievements was the measurement of Himalayan peaks, including the first accurate calculation of the height of Mount Everest, which was later named after George Everest. So, the Great Trigonometric Survey was not just about maps. It was about laying the foundation for modern geography, cartography, and land administration in India. Surveying in India has evolved over centuries. In ancient times, land division was seen in the Indus Valley and Mauryan records. During the colonial period, the Great Trigonometric Survey, 1802 to 1871, mapped India with precision. After independence, national mapping organizations were established. In the 21st century, modern tools like GIS, remote sensing, and programs like Swamitwa and Naksha are driving land governance. Surveying today ensures accurate land records, infrastructure planning, agricultural management, and supports policy making.
Surveying can be classified into two main types. Plane surveying is a type of surveying where the Earth's surface is considered flat and the curvature of the Earth is ignored. It is suitable for small areas, usually less than 250 square kilometers. Calculations are simple, using plane geometry and trigonometry. It is commonly used for cadastral surveys, topographic surveys, and construction projects. For larger areas, however, geodetic surveying is required because Earth's curvature cannot be neglected. Geodetic surveying is used for large areas where the curvature of the Earth cannot be ignored. It involves highly precise instruments and methods to measure long distances and large regions. This type of survey establishes control points that are used for mapping and national-level projects. It is essential for large infrastructure, scientific studies, and accurate global positioning. Unlike plane surveying, it applies advanced mathematics and geodesy to ensure accuracy. Methods of surveying. Surveying is the technique of determining the relative position of points on, above, or beneath the Earth's surface. It can be classified based on the method or the nature of the survey. Below are the major methods of surveying. 1. Astronomical surveying. Involves mapping sections of the sky. Helps in determining geographic positions using celestial bodies. 2. Boundary surveying. Determines the boundaries of land sections. Used in legal property disputes and ownership documentation. 3. Construction surveying. Supports construction and engineering projects. Ensures structures are built in the correct location and elevation. 4. Control surveying. Establishes reference points or control points. These points ensure accuracy in other types of surveys. 5. Hydrographic surveying. Focuses on bodies of water, lakes, rivers, oceans. Aids navigation, harbor construction, and underwater mapping.
This slide explains the classification of surveying based on the instruments used. Different instruments are chosen depending on the type and accuracy required in a survey. Common instruments include the chain for measuring distances, compass for determining directions, and plane table for map-making on-site. Advanced tools like the theodolite and tachyometer are used for precise angle and distance measurements, while photographic methods involve using cameras for mapping. The most modern tool shown is the total station, which combines electronic distance measurement with angle measurement for highly accurate digital surveys. This slide presents an overview of traditional surveying instruments that have been widely used in the field before the advent of modern electronic devices. The chain is a basic yet essential tool used for measuring horizontal distances. It typically consists of linked steel wires like Gunter's chain, 66 feet, and requires 2 operators along with ranging rods to ensure alignment. The plane table is an instrument used for field mapping and plotting simultaneously. It features a drawing board mounted on a tripod and is best suited for small area surveys where moderate accuracy is acceptable. The compass, particularly the prismatic compass and surveyor's compass, is employed to measure bearings and directions, assisting in the orientation of survey lines. Lastly, the theodolite is a precision instrument capable of measuring both horizontal and vertical angles. It is commonly used in triangulation, traversing, and detailed engineering surveys. Operating a theodolite requires skilled handling and accurate leveling to ensure reliable data collection. These traditional instruments laid the foundation for modern surveying techniques and remain important for understanding basic surveying principles.
An overview of land governance in the pre-digital era. Land ownership documentation. Manual records. Land ownership and tenure rights were recorded on paper, stored in ledgers or government offices. These documents included deeds, title certificates, or other proof of ownership. Inaccuracies and fraud. Physical records were often misplaced, damaged, or manipulated, leading to disputes over ownership and land rights. Land registration. People had to visit land offices to register ownership, update records, or verify land titles. This process was slow and often involved significant bureaucracy.
Cadastral mapping. Field surveys. Land boundaries were surveyed using conventional tools such as chains, compasses, and basic surveying instruments. The accuracy of these surveys depended on the skills of the surveyor. Hand-drawn maps. Land parcel boundaries, land use, and administrative boundaries were drawn manually on paper maps, which could degrade over time. The maps were not always up to date, leading to inconsistencies in land records. Discrepancies. Discrepancies between maps and actual land use were common, especially in rural or remote areas, resulting in overlapping claims and confusion.
Third point is natural resource management. Manual surveys, natural resources such as forests, water bodies, and minerals were managed based on periodic surveys conducted by field officers. These surveys were typically infrequent, and the data was recorded on paper. Inefficient monitoring. Monitoring resource extraction, environmental changes, and land degradation was inefficient without real-time data, leading to overexploitation and environmental damage.
Fourth point is land taxation and valuation. Physical assessments. Land tax was based on physical assessments conducted by tax officials who visited properties. This system was highly subjective and prone to inconsistencies, corruption, or bribery. Outdated records. Land value assessments and tax registers were often outdated, leading to inequitable taxation and revenue losses for governments.
Today, we discussed the traditional methods of surveying. In the next video, we will move to modern surveying techniques and explore powerful tools like GPS, remote sensing, UAVs, and LiDAR, which have completely transformed the way we survey land today. Thank you for watching, and see you in the next session.